Hello students, next we will try to understand construction and working of P-channel MOSFET, which will be almost exactly similar to what N-channel MOSFET is, the construction and working part. Only the difference will be the types of semiconductor will change. Okay, so now we are going into enhancement type, that is P-channel MOSFET, and try to understand the electrical characteristics of the P-channel MOSFET. Okay, so now as you already know the construction and working of N-channel MOSFET, you have to keep on interpreting what I am trying to design. Okay, so the first thing is you have to take a P-type semiconductor. Okay, P-type semiconductor. So now you have understood that whether it is depletion type or enhancement type, if you want to design an N-channel depletion type or enhancement type MOSFET, you have to take N-type semiconductor, and if you want to design a P-channel depletion type or enhancement type MOSFET, you have to use P-type semiconductor. So it is very evident. Okay, and these two terminals are called as, source and drain, and as it is a P-type semiconductor, it will have large amount of holes which will be available as majority charge carrier, through because of which current will flow from source to drain. Okay, now on the one side of the semiconductor you dope. Now to form a p-n junction, what has to be done is, we have already p, then you have to form an n region. To form an n region, what you dope is, you dope pentavalent impurity, and this terminal will be called as substrate. Okay, and on the other side of the substrate, over the semiconductor layer, you form a layer of silicon dioxide oxide, which acts as an insulator, and over which there will be a metal deposition. Okay, over which metal deposition, and the terminal which will be taken out, and this terminal which will be taken out is called as gate. Okay, and what has to be taken care when you construct a P-channel MOSFET, you have to make sure that you have to keep on doping the impurity, so that this N region will keep on extending towards the substrate. So when it will keep on extending towards the substrate, at some point the channel width will be 0, and this N channel will almost extend towards the capacitor formed by metal oxide semiconductor. Okay, so this is the construction details of your P channel MOSFET. Okay, so now as there is no channel width, will there be any flow of current from source to drain when we apply potential between source and drain? Of course not. So in enhancement type P-channel MOSFET, also the transistor is normally off. All these MOSFETs are used as a switch in digital circuits, so either it will be on or it will be off. So normally, mostly the circuits which we will be needing will be normally off. So mostly the circuits which we use is enhancement type MOSFET. Okay, so now the substrate is always internally connected with source. So this is construction part of P-channel MOSFET. Okay, and then now we will try to understand the working. So we will draw the diagram once again. This two terminal will be called as source and drain. The N region will be extended up to the MOS formed by the capacitor formed by the MOS, metal oxide semiconductor. This terminal is called as substrate, internally always connected with the source. Over on the other side of the substrate, over the semiconductor layer, we deposit oxide, which is mostly silicon dioxide, over which there will be a metal deposition, and that terminal will be called as gate. Okay, so we have large amount of majority charge carrier. As we have taken p-type semiconductors, the charge carriers are holes. So now when you apply potential between drain and source, we have to apply in such a way that charge carrier will move from source to drain. सोर्स से ड्रेन की तरफ जाएंगे, है ना, तो ऐसा पोलैरिटी लगाना पड़ेगा. तो क्या करेंगे, सोर्स शुड बी कनेक्टेड टू positive and drain should be connected to negative. As this potential is applied between drain and source, that potential is called as VDS, and we are supposed that by applying this polarity, charge carrier should move from source to drain. Current should flow through the transistor. That current will be IDS. The current will be IDS. Okay, now what we will do is we will apply gate potential as negative, positive, negative, positive. This is through switch minus, sorry, this is minus and this is plus. This potential is applied between gate and source, therefore the potential will be called as VGS. So now I have kept the switch open, that means there is no gate to source potential. Okay, there is no gate to source potential. Only potential which we have applied is between source and drain. And when such a polarity is applied, positive charge will repel the holes and they should move towards the drain, and they should get attracted by the negative terminal. But the N region, in case of P channel MOSFET, the N region substrate has been extended almost towards the capacitor formed by MOS, metal oxide semiconductor. So is there any channel for this charge carrier to move? The channel has been blocked by the N region. So no charge carrier will move from source to drain. So when VGS is not applied, that means VGS is 0. Of course IDS, उस टाइम पे कोई चार्ज कैरियर के लिए जाने की जगह है क्या सोर्स से ड्रेन में? नहीं, तो करंट विल बी 0. Okay, current will be 0, IDS will be 0. Okay, so and again if you compare the working with the depletion type P channel MOSFET, in that case what will happen is when VGS is 0, the channel width is maximum, no external potential, no external force has been applied on the charge carrier. Charge carrier will be easily moving from source to drain, so IDS will be maximum in that case. Depletion type P channel MOSFET, so we say normally on, depletion type is normally on. In this case IDS is 0, no current is flowing through the transistor, so we say an enhancement type is normally off. Now when we apply potential to the gate to source terminal, that means VGS starts increasing. As soon as VGS is applied, negative charge starts accumulating in the capacitor formed by metal oxide semiconductor. So these electrons will repel the electrons of this N region. Okay, they will repel the electrons from this N region. So all these electrons will move towards the substrate. That means there will be a channel which will be formed. There will be a channel now start creating, okay, so that this charge carrier will be moving from source to drain. So when VGS is increased, IDS also increases. Okay, and when VGS is maximum, that means large amount of negative charge accumulates around, so they will repel all the electrons which has been extended up to the MOS, and this N region, right, these electrons will get attracted by the positive terminal. So what will happen is when this electrons which was extended up to the capacitor formed by MOS is pushed towards the substrate, what happened is eventually there will be large amount of channel width available for this charge carrier to move from source to drain. मतलब जो resistance था, है ना, ये holes के लिए source से drain में move करने के लिए धीरे धीरे वो resistance कम होते जाएगा. कैसे? क्यों? क्योंकि हम ये इलेक्ट्रॉन्स जो एक्सटेंडेड थे मॉस तक, उसको हम लोगों ने रिपेल करते जाएंगे, है ना. जितना चार्ज कैरियर यहाँ जमा होते जाएगा उतने इलेक्ट्रॉन्स यहाँ रिपेल होते जाएंगे. रिपेल हो रहे तो वो कहाँ जा रहे हैं? सबस्ट्रेट की तरफ जा रहे हैं. और अगर सबस्ट्रेट की तरफ जा रहे हैं तो वो चैनल विड्थ खोलते हुए जा रहे हैं, है ना, और चैनल विड्थ बढ़ेगा तो चार्ज कैरियर कैन इजीली मूव फ्रॉम सोर्स टू ड्रेन. सो व्हेन VGS इज maximum, IDS also is maximum. Okay, so this is construction and working of P channel enhancement type MOSFET. Okay, so for first thing what you have to do is you take P type semiconductor. Okay, the terminals will be named as source and drain. Then on one side you form a PN junction. So to form a PN junction, we do pentavalent impurity so that we get N region, but that N region will be extended almost towards the MOS. So on the other side, what you have to do is, over the semiconductor layer you have to deposit oxide, which acts as an insulator, over which there will be a metal deposition, and the terminal which will be taken out will be called as gate. And we know that substrate and source are connected internally always. Okay, and when potential is applied, how the potential is applied? Source should be connected to positive, drain should be connected to negative, so that holes are repelled from the source and move towards the drain. But because of this N region which has been extended almost to the capacitor formed by MOS, there is no channel width, no current flows, therefore the transistor is normally off. And when you keep on applying VGS, as you keep on gradually increasing VGS, what happens is this electrons from the N region will be kept pushing towards the substrate, and when they are kept pushing towards the substrate, what will happen is the channel width will open, and as soon as the channel width is open, that means charge carrier can move through the channel from source to drain. So we say the resistance keep on decreasing, the current keep on increasing, and when VGS is maximum, उस टाइम पे channel width is maximum and therefore large amount of current flows from source to drain, so current IDS will be maximum. Okay, so this is the operation of P channel MOSFET. Okay, now let us try to understand or see the difference between the symbolic representation of N channel and N channel P channel MOSFET for both depletion and enhancement type. Okay, so this is if you remember, I have given you the symbolic representation of depletion type MOSFET, N channel, P channel. Okay, but here I will compare these two. If I am not wrong, I have made a mistake in giving you the symbolic representation there. So just to focus the symbolic representation here for depletion type and enhancement type MOSFETs. Okay, so depletion type MOSFET, and this is enhancement type MOSFET. Okay, the symbolic representation we can understand by logically. देखो कैसा होता है, this is the transistor. Now here, in case of depletion type MOSFET, current will flow, it is normally on state, current will flow from source to drain even when VGS is not applied. Okay, so we show a single line between drain to source. It is not disconnected नहीं, connected show करना है हम लोगों को, ठीक है, connected show करना. And then we have a substrate which is internally connected with the source. So this is substrate, and there is a gate terminal which will be exactly in opposite direction to that of gate. Okay, so this is the symbolic representation for depletion type MOSFET. Okay, drain to source, single line, then you have the substrate, and then you have the gate, drain, source, and this is substrate. Okay, so if the arrow mark is inward, it is N channel, and if the arrow mark is outward, it is P channel. Okay, and now enhancement type MOSFET. Enhancement type MOSFET, we have to draw 3 lines. Okay, this is separated individually, and then we show this substrate and source which is connected internally. Okay, substrate and source are connected internally, and in front of substrate there will be a gate terminal. Okay, so this is this is gate, this is drain, and this is source. Okay, similarly gate, as drain and source are not directly connected, in between that there is a substrate, therefore we are showing it disconnected. Okay, so this is again drain, source, and gate. If the arrow mark is inward, it is N channel. If the arrow mark is outward, it is P channel. Okay, so just forget the symbolic representation which I have told you in depletion type MOSFET. Actually what I did is I have told you the symbolic representation of enhancement type MOSFET there. Okay, so that was the mistake. So this is the depletion type MOSFET, symbolic representation of N channel, P channel depletion type MOSFET, and this is the symbolic representation of N channel and P channel enhancement type MOSFET. Okay, so this is all about MOSFET. Okay, so this unit had the unit which we were trying to understand was field effect transistor, and field effect transistors, the two examples of field effect transistor was JFET and MOSFET, and MOSFET was further classified into depletion type and enhancement type. So we have completed every circuit of this unit. Okay, so this is what we were supposed to understand in unit number 3. Next we will try to understand unit number 4, which are uni-junction transistors. What exactly that means, of course when we will start the unit we will try to understand that. I hope you have understood all these topics, and if you have any query, of course you can call me or you can message me and you can ask me that questions. Okay, thank you so much.